Welcome to the second lecture of the series Energy Management Preparation to Become Certified Energy Manager. In this lecture, we will talk about understanding economic analysis of energy choices. Have you ever wondered how to choose the best option when faced with multiple choices to achieve a specific goal? Well, that's where economic analysis comes in. It's all about making informed, data-driven decisions based on costs and benefits. At its core, economic analysis is the process of formulating, estimating, and evaluating the results of different options. Let's break it down. First, we have formulating. This is where you clearly define your goal and identify the possible options to achieve it. For example, if your goal is to reduce energy consumption in a building, you might consider upgrading lighting, improving insulation, or installing a new HVAC system. Next is estimating. Here is where we look at both costs and benefit. Costs include purchase price, installation, energy, maintenance, and even indirect costs like overhead. These can be estimated using vendor quotes, past experience, or reliable databases. On the other hand, benefits focus on savings like reduced energy consumption or increased efficiency. These are quantified in monetary terms to make comparisons easier. Once you have estimated the costs and benefits, it's time for evaluation. This step compares your options to see which one is most economically viable. The aim to determine if a project is truly cost effective. The final step is decision making. Using the insights from your analysis, you can choose the best option, whether it is the most cost effective or the one that balances other priorities like ease of implementation or energy savings. An important concept in economic analysis is the time value of money. A dollar today is worth more than a dollar tomorrow because of its earning potential. This principle helps evaluate project costs, benefits, and cash flows over time. Economic analysis also dives into understanding how energy is used and potentially wasted, and identifying cost-effective solutions. It's a system approach and often powered by computer simulations in order to have the best results. In summary, economic analysis is a structured approach to decision making that considers all relevant costs and benefits to select the best option. It requires skills in cost estimation, benefit quantification, and applying the time value of money. Now, we will explore the essentials of project costs, benefits, interest rates, and the time value of money. These concepts form the backbone of economic analysis and are crucial for making informed decisions. Let's start with project costs and benefits, often referred to as cash flows. These are the financial components of any project, split into two key categories: costs and benefits. Let's start with costs. Costs include initial expenses like equipment purchase and installation. Also, operating costs such as energy, maintenance, and repair expenses. Costs also include indirect costs like overhead or hidden expenses tied to the project. For benefits, benefits include positive outcomes like energy savings, which reduce utility bills, increased efficiency, improving processes, and reducing wastes. Also, environmental benefits like lower emissions or reduced wastes. And salvage value. Salvage value reflects the asset's value at the end of its useful life, either as resale value or disposal costs. Let's talk about interest rates. The interest rate, or I, represents the cost of borrowing money or the return on investment. It's often used interchangeably with the discount rate or minimum attractive rate of return, or MARR. The MARR, or hurdle rate, is the minimum rate of return required for an investment. It's also essential in net present value calculations to assess project viability. The time value of money is a core concept in economic analysis. Simply put, a dollar today is worth more than a dollar in the future because of its earning potential. This is influenced by factors like interest or the return earned on money and inflation, which reduces purchasing power over time. The core principle behind present value is that money has a time value. A dollar today is worth more than a dollar tomorrow. Think about it. If I offered you a $100 right now, or $100 a year from now, which option would you choose? Almost everyone would take the $100 today. But why? There are several reasons. First, potential earnings. If you have a $100 today, you could invest it. Even a small interest rate means that in a year you would have more than $100. Second, inflation. The purchasing power of money can decrease over time. That's $100 a year from now might not buy as much as $100 today. And finally, there is uncertainty. There is always a chance that you might not actually receive the money in the future. Let's illustrate it with a simple example. Imagine you have the choice $100 today or $100 1 year from now. Most would choose today's money. Let's say that you could invest it at a 5% interest rate. In a year, you would have $105. So the future $100 isn't equivalent to today $100. It means the present value of that future $100 is less than 100. This brings us to the present value formula, which says PV equals FV divided by 1 plus R power N. Let's break down what each part means. PV, this is the present value, what the future money is worth today. This is what we want to calculate. FV, this is the future value, the amount of money you will receive in the future. R, this is the discount rate. This represents the rate of return you could earn if you invested the money today. It reflects the time value of money and often incorporates risk and inflation. N, this is the number of periods, usually years, you have to wait to receive the future value. Let's use our previous example. FV is $100. R is 5% or 0.05 and N is 1 year. So PV or present value equals 100 divided by 1 plus 0.05 power 1 or 100 divided by 1.05, approximately 95.24. This means receiving $100 a year from now is equivalent to receiving about 95.24 today, given a 5% discount rate. Now it's important to understand that present value is a concept rather than a strict mathematical law. The discount rate R is somewhat subjective. It depends on factors like risk tolerance, investment opportunities, and inflation expectations. So, present value calculations are often estimates based on assumptions. The key takeaway is that money has a time value. Understanding present value allows us to compare cash flows occurring at different times, make informed investment decisions, and accurately assess the true value of future payments. By mastering project costs, benefits, interest rates, and the time value of money, you will be equipped to perform thorough economic analysis and make smarter investment decisions. Now, another spectrum of economic analysis. How do we decide if an investment is financially viable? Measures of worth provides a structured way to evaluate project costs and benefits, helping us determine whether to accept, reject, or rank multiple investment opportunities. Measures of worth help quantify the financial attractiveness of a project. Some methods, like the payback period, focus on how quickly an investment is recovered, while others, like net present value or NPV and internal rate of return (IRR), consider the time value of money for a more accurate analysis. The simple payback period, or SPP, measures how long it takes to recover the initial investment from project savings. It's calculated using the formula simple payback period equals initial cost divided by annual savings. For example, a $10,000 project that saves $2,000 annually has a payback period of 5 years. Decision rule. A project is considered attractive if the payback period is within a predetermined limit. What about limitations of SPP? It ignores the time value of money. It does not consider savings beyond the payback period. It favors short-term projects which might not be the best long-term investment. That's why we need the discounted payback period, which improves on this by applying a discount rate to account for the time value of money, making it a more accurate measure. Unlike payback method, net present value, or NPV, accounts for the time value of money. It calculates the difference between the present value of future cash flows and the initial investment using a discount rate. The formula for NPV is NPV equals present value of cash flows minus initial investment. For example, if you expect to receive a $10,000 in 5 years and the discount rate is 10%, its present value is $6,209. Decision rule: if net present value is positive, the project is profitable and should be accepted. If NPV is 0, the project breaks even. A negative NPV means the project loses value. The internal rate of return (IRR) is the discount rate at which NPV equals 0. In other words, it is the expected rate of return on an investment. IRR is the rate where present value of costs equal present value of savings. Decision rule: if IRR is greater than the minimum attractive rate of return, or MARR, the project is worth investing in. What about limitations? Some cash flow patterns can have multiple IRRs, making interpretation tricky. It works best when a project has a single upfront investment followed by returns. Why these measures matter? By using these financial measures, businesses and organizations can make data-driven decisions about investment. Also, identify projects that offer long-term financial benefits and compare multiple options to select the most cost-effective one. In summary, measures of worth help evaluate the financial viability of a project, while payback period offers a quick risk assessment. NPV and IRR provide a deeper, more accurate economic analysis. Want to make smarter investment decisions? Start applying these financial tools today. Thanks for watching. We will see you in the next lecture. And please subscribe to the channel and explore our other videos for more insights into energy and sustainability.